So today we're going to look at trying to verify whether a point is a solution of a linear inequality, and our focus today is going to be algebraically. That's the technique we're going to look at today. Not graphically, just algebraically. First, let's review real quick what it means to be a solution. Of course, a solution is any value that will make a true statement. That's what we're looking for. So here's a couple quick examples of some non-linear inequalities. Is just regular old equations. Is x equals 3 actually a solution to 2x plus 7 equals 13? Well, we've known this for a long time. We just substitute the value in. So we're going to substitute x equals 3 in and then simplify. Of course, 2 times 3 is 6. 6 plus 7 is indeed 13. So yes, indeed, it is a solution. A non-example, is x equals 3 a solution to negative 4x plus 9 equals 5? Again, the procedures are all the same. We're going to substitute x equals 3 in to our equation. We'll multiply here, simplify. Negative 4 times 3 is negative 12, and negative 12 plus 9 is negative 3. So this is not a solution. That's how we learned how to do algebra, a long time ago anyways, but guess what? It still works the same with inequalities. Let's check that out. So here we have an inequality. Is the point negative 3, 2 a solution to y is less than 3x plus 14? I have a linear inequality here. Well, the procedures are going to be the same. Of course, negative 3 represents your x, 2 represents your y, so I'm going to substitute those values in. So the y is a 2, the x is a negative 3, and from there I'll simplify. 3 times negative 3 is negative 9, and of course negative 9 is, or plus 14 is 5. And is 2 actually less than 5? Well, of course it is. 2 is definitely less than 5. So this is a solution. Let's try another. What about is 5 negative 4 a solution to 2x plus 3y is greater than or equal to 6? Try this on your own. Okay, just like before, we are going to substitute our values in. This time x equals 5, y is negative 4. I gave you a different form of the line here. I gave it to you in standard form here just to show you that the procedures are the same regardless of the form. So 2 times 5 and 3 times negative 4, I've got 10 plus negative 12. And when you simplify that further, negative 2 is not greater than or equal to 6. So this would not be a solution. It really is that simple, but I do want to point out one super important thing, and we have to be really careful with our greater than or equal to's versus our greater than, or our less than and equal to versus our less than's. Let's see what I mean by that. Here's another example. Is the point 4, 5 a solution to y is greater than or equal to 1/2 x plus 3? Just like before, same procedures. I'm going to plug in and simplify, and you can see as I simplify that 5 is indeed greater than or equal to 5. 5 is equal to 5. Therefore, this is a true statement. 5 is equal to 5. However, sometimes we get a situation like this. Now, I put this in the non-example. Can you go ahead and try this on your own to see if you agree it's a non-example? Alright, just like before, we are going to substitute our values in. I've got 3 times negative 1, negative 1 for my x value, 4 times 4, 4 for my y value, gives me negative 3 plus 16, and in this case I get 13 is less than 13. Now think about this. Why did I say this was a non-example? Why did I say this did not work? Well, because 13 is not less than 13. It is equal to it, but it is not less than. And that little sign right there makes a big difference. So pay really close attention to an equal to, greater than or equal to, less than or equal to, and just greater than or less than signs. Hope this video helped. Let me know if you have any problems in the comments below. Thank you.